Hello everybody, in this video we're going to be talking about 3 different ways to make vectors in MATLAB. So we're already familiar with one way, which was introduced in the previous video, and that's by just hard coding a vector by hand. So I can say v, let's say for vector, equal to, place square brackets, and I can say, well, maybe I want it to be 3, 1, 4. Oops. And remember, the commas aren't necessary. I could just use a space instead and MATLAB would know what I'm talking about. But just to make it a little easier for us to read, let's use the commas. I'm going to press return. And we can see now in the workspace, we have our vector v. But what if we wanted to create something that had 1,000 places, for instance? Maybe I want to create a vector that goes 1, 2, 3, all the way up to 1,000. That definitely wouldn't be realistic to do by hand. And one way that we can do that very quickly is by using the colon. So on your keyboard, it's this symbol here. But before we do that, let's practice again using the help function. So I'm going to say help colon, hit enter, and let's scroll up to the top. So what this is saying is the notation j colon k. What that does is it says start at j and go up to k. And a different notation here, so a little bit different if we have 2 semicolons. What it's saying is start at j, go up to k, but you're skipping by I units every time. So for instance, if I was 2, I'd be like counting by 2s. If this is a little bit confusing, I think with some examples it'll become more clear. So let's try it out. Maybe I'll even clear the screen first just so that we're not looking at all of that. But let's create a new vector. I'll call it w. And let's say this is equal to, let's go from 1 to 10. So I just do 1 colon 10. And we can see now this is a vector that starts at 1. It goes to 10. And notice that the increments here, it goes up by 1 each time. So as we saw in the documentation, this would be equivalent to writing 1 colon 1 colon 10. So the default kind of is assumed that you want to jump by 1 each time. What if I wanted to start at 1, go up to 10 but don't go past it, and go up by 2 each time? Well, I could say let's redefine z to be 1, 2, 10. And we can see here we go 1, 3, 5, 7, 9. But we don't include 11 because that would go past 10. On the other hand, if I did something like 1 to 11, we can see that 11 gets included here. Maybe one other thing that, well, not one other thing, but another thing that we can consider is, what do you think will happen if I do something like 1 colon 20.3? Take a minute to think about it. Do you think it's going to give an error? What do you think is going to happen? Going to press enter, and we can see here we go 1, 2, 3 all the way up to 20. We don't include 21 because 21 is greater than 20.3. So you don't need to put an integer as your endpoint. It could be here 20.3, a rational number like we saw. Whatever you put, it's just not going to go past it. We could also try 1, 2, 20.3. And here we see it stops at 19 because we're counting by 2s. And if I add 2 to 19, that's going to be greater than 20.3. So far I've showed you how to make a vector that's increasing, so I'm adding each time. But I could just as well subtract every time. So instead, what if I said 1, and let's say I want to count by -3, and I don't want to go past -100. And I can press enter, and we can see here we go 95, -98. But then if we were to have one more, that would be -101, so it would go past -100. So another thing that we could do is we could say, well, 1, -3, -101, and now we can see it's included here. Oops, did I do something wrong there? Oh, see, I did by -1. Let's fix that. So all I've done here is press the up arrow to get our old statement, so the -3, and go -101, And here we can see negative 98, negative 101. Great, so this colon command, this gives us one way of making vectors very fast, very nicely. And now I'm going to show you one last method in this video. So this is going to be, okay, before I introduce the last method, one more thing I want to show you, one more. What do you think is going to happen if I do 1 colon negative 10, let's say? I'm going to hit enter. So this didn't give us an error, but it's saying it's a 1 by 0 empty row vector, and we can see this answer here is an empty vector. There's nothing in it. In fact, if I do the length of answer, for instance, I get it has length 0. So what's going on here is, remember, the default assumption is that you want to increase by 1 every time. So it tries to do 1 plus 1, that would be 2, but it's gone past negative 10. So that's the issue. We're not going towards negative 10, and that's why we get this empty row vector. Okay, now as promised, the last way to make these vectors is going to be using the command linspace. It's similar to linspace, just without the E. So again, let's do help linspace. And what this gives us, so what you pass it is x1, x2. We're not actually going to use it with just 2 arguments usually, but what this does is it generates a row vector of 100 equally spaced points between x1 and x2. So the default here is it gives you 100 points, but typically we're going to want to specify ourselves how many points we want. So the first 2 arguments, that's your start point and your end point, and this last argument, n, tells you, well, how many points do I want to make? So let's try it out a couple of times. So let's say linspace, let me maybe have my mouse not cover it, of, let's say, go from 1 to 10, and I want 4 points. So you can see here, I have 1, 4, 7, 10. So it starts at 1, ends at 10, and I have 4 equally spaced points. So notice the distance between each pair of points going from left to right is 3. So linspace is going to be very helpful for us when we get to plotting. So for instance, maybe I need to specify the domain of a function that I want to have plotted. So maybe I want to plot from 0 to 100, and I want to have, I don't know, maybe 50 points. So this is going to give us a way to easily generate those points. Something else we can try. So in this example, the numbers look pretty nice. But for instance, I could try something like linspace of 1, 10, 6. And we can see here that the numbers look a little bit more random each time. So you can see it's going up by 1.8 every time. All right, everyone, editing me here, I realized I forgot to show one more thing in this video. And that's, I want you to imagine a situation where, let's say I want to do linspace of 1 to 10, and you can say, imagine again, you're plotting, I want 1,000 points, for instance. If I hit enter, I have this giant list. So again, if I wanted to scroll back up to where I was, this looks terrible, right? There's way too much on the screen. So let me start by just clearing the screen. And the way that you want to suppress output is you're just going to put a semicolon at the end of the statement. So we have linspace 1, 10, 1,000, and semicolon, and now it's still saved as our answer. The only difference is that it doesn't get printed out. So this semicolon is going to be very useful for us when we define functions and scripts in the next video. But for now, this is where I will end the video. Thank you for watching, and I will see you in the next one.